Assalamualaikum warahmatullahi wabarakatuh. Ketemu lagi ya, kita kali ini masih membahas ya video-video tentang trik sama tipsnya ya dari CSI. Sekarang kita mau lihat video tentang autocad constraint. Jadi itu pemodelan untuk dinding ya, dinding atau nanti kita bisa bikin ram. Terus biasanya kan kalau kita bikin ram kesulitan ya untuk menyatukan selnya itu. Nah, ini solusinya ya. Kita lihat aja videonya.
In this video, I will discuss the benefits of using the auto edge constraint assignment in the Etabs program. I'll demonstrate how the application of the auto edge constraint on shear walls will affect load distribution from the top of the walls to the bottom. So let's get started. Let's take a look at the model. So we have 4 shear walls here. You'll notice that the wall on the far left side has a 5x5 mesh on the top as well as the bottom of the wall. So there's going to be nodes that are connected, therefore load distribution will not be an issue for this specific wall. For the second wall, there's a 4x4 mesh on the top and a 5x5 on the bottom, resulting in mismatched nodes. So by default, this shear wall will only have load distribution in the far left and far right hand side of the wall. This is where the auto edge constraint can come into play, but we'll get to that. For this third wall, I'm going to do an internal mesh, a 5x5 on the top and bottom. To do that, I'll go to the Assign menu, Shell, Wall Auto Mesh Options, and I'll select the second option, Mesh Object into 5 vertical and 5 horizontal pieces. So you can see a 5x5 internal mesh has been applied. And the fourth wall on the far right hand side is going to be identical to the second one, but we will apply an auto edge constraint to this second wall. So how do we do that? So what I'll do here is I'll select these specific portions of the wall. We'll go to Assign, Shell, Auto Edge Constraint. Okay, so now before we assign the auto edge constraint, let's have a discussion as to what it actually is and does. So typically in finite element analysis, shell elements are connected to other elements at the corner joints only, as I was saying. When an element does not frame into a corner joint of a shell element, but instead frames into the edge of a shell element, no connection exists between the element and the shell element. So this is where the Etabs auto edge constraint feature can be used to specify that elements framing into the edge of a shell can be connected to the shell element. So essentially Etabs internally takes care of a connection between these elements by constraining joints lying along the edge of a shell to move with the edge of the element itself. So we expect proper load distribution from the top of the wall to the bottom. So let's quickly assign that. There are a few different options. Creating an edge constraint around the walls and floors. This is only a wall model. Or there's an option to apply to a full structure. We will not be using that option in this model. Okay, so I'll click Apply, and you can see the selected shell elements have an edge constraint applied to them. Let's go ahead and run the model and see how the deflected shape and the load distribution are affected by the auto edge constraint. Okay, so the model has been run. Let's take a look at the deflected shape. The wall on the left.
Nah, bisa dilihat di sini ya. Jadi dia kan ada batasan di sini ya. Ini katakanlah gridnya ya. Nah, yang menarik di sini kan jadi satu ya. Ini dia jadi batasan ini terkoneksi ya satu sama lain. Nah, ini kita untuk desain ram itu jadi sangat mudah ya. Jadi sangat memperhitungkannya gaya-gaya dalamnya nanti bisa lebih maksimal ya. Oke, lanjut.
With the 5x5 mesh is connected with no issues, as you can see, as is the case for the second and third walls that used the auto edge constraint and the 5x5 internal mesh. but the wall on the far right-hand side is only connected at the far left and right-hand sides, therefore causing an issue. Again, there was no auto edge constraint assigned to the wall on the right. And of course, as you can see, there is a connectivity issue. Okay, so what about load distribution? If we stop the animation, let's take a look at some shell stresses. So to view that, we'll go to Display, Force Stress Diagrams, Shell Stresses and Forces. We're interested in taking a look at the live load, which is actually a lateral load in the X direction applied to the tops of all of these walls. We'll look at the S22 component. Okay, so here's the stress distribution from the top of the wall to the bottom. Looks very uniform as expected for this far left wall. And as you can see, with the use of the auto edge constraint, the stress distribution from the top of the wall to the bottom is quite uniform, just as it is for the wall on the left. Uniform stresses here as well for the third wall, but here's where the problem occurs. If we zoom into this fourth wall, where there were no auto edge constraint applied, the stress distribution is non-uniform, quite jagged. Load distribution is only being distributed at the far left and right end corners of the wall. So you can see the auto edge constraint is quite a powerful tool. This can be used for simple situations like this, shear walls that have curves in them, shear walls that span multiple stories, for circular ramps, for garages, ramps, or any type of unique situation.
Oke, jadi cukup menarik ya teman-teman video kali ini untuk menambah wawasan kita ya. Semoga bermanfaat. Assalamualaikum warahmatullahi wabarakatuh.